In this problem, we're trying to determine the critical points of the given function. So to find critical points, we need to figure out what the derivative of this function is. So f prime of x will be 2 times 1.5 is 3, x to the first power plus 2.7, and minus 3.5 goes away. So now we need to figure out the critical points are where the slope is 0. So here's the slope on this side, and we want to determine what value of x will pinpoint a point that will have a slope of 0. So we solve this equation, get negative 2.7 equals 3x, and so x equals negative 2.7 divided by 3. So we will come over to our calculator and type in negative 2.7 divided by 3 to give us negative 0.9. So that's a critical value. Now we want to determine whether that critical value represents a minimum, a maximum, or neither. So we will perform our first derivative test, and we'll go ahead and just draw a number line and label negative 0.9. Now we want to test a point to the left and to the right. So looks like negative 1 is to the left of negative 0.9 and 0 is to the right, so those are always easy values to pick. So this is x equals negative 1 and x equals 0. And of course we want to plug this into the derivative function because we want to see is the function increasing or decreasing until it reaches the critical value. If it's decreasing then increasing, we know we have a min. If it's increasing and decreasing, we know we have a max. Again, the beauty of the critical points is that in order for a slope to change from positive to negative, it must pass a slope of 0. So because there's only one place where that happens, we know that there's one of 3 possibilities. Well, 4 possibilities. Goes down, goes up, goes up, goes down, goes up, but then continues to go up, or goes down, continues to go down. So sometimes we will find fluke critical points. So we will find that f prime of negative 1, in other words, the slope at negative 1 is 3 times negative 1 plus 2.7, which will be negative 0.3. And f prime of 0 will be 3 times 0 plus 2.7 is 2.7. So we don't really care about the numbers, we really just care about the signs, because you and I could pick 2 different test points. And so we notice that this thing has a 0 slope here, but up until that point it's decreasing, and then after that point it's increasing. So we know that this is more parabolic, but the bottom line is that this is a global min.